Hi everyone, welcome back to another episode of Backend FM. And before we even get started, I would like to wish you a happy new year and pray that all your goals this year you are able to achieve them. All right, so this is another episode, and in this episode, we want to start discussing, a very important topic that has taken over the world of software engineering, which is of course AI and AI engineering. Today's episode, we have a very good guest, and he's a software engineer and also an AI engineer. He's going to break down to us what production ready AI engineering is all about and also talk to us about AI engineering in general. So, I would like to introduce him. Param is a software engineer and also an AI engineer. So, Param, you're welcome to Backend.
Thanks, Salmon. Thanks for inviting and thanks for hosting this. By the way, to the community, Happy New Year. And I'm very happy to be here and sharing my knowledge wherever possible around AI engineering.
All right, that is awesome. So, like I said, for today, we want to understand everything that relates to AI engineering and also how to build production-ready AI systems. All right. So, I would have series of questions that I would want to ask, and then you're going to shed insight and throw more light on these questions. And at the end of the day, we are going to also get feedback from our community, and then we are going to share them to you to respond, and we are going to share it on the comment sections.
Sure, sure.
Question that I basically have is, what is production ready AI actually means? Now, the reason for this question is more because software engineering over the years, we've actually been building systems. We've built different large scale systems, small systems, distributed and monolithic applications. Now, with the advent of this AI, what does it really mean to build AI systems that are production ready? So, yeah.
Got it. To be honest, that's a very good question. To be honest, the software engineering principle might not change with AI. So the systems what we have built, either monolith or distributed system, it will be the same. Only difference is now we are enhancing a lot of features, lot of systems built on top of AI. So automatically that will be the additional complexity which will get added to the existing software engineering principle. So in my opinion, I think 90% of AI engineering is exactly the software engineering what we have learned throughout the years. So at the end of the day, what API we create, whether it is an AI API or a backend API, the actual production readiness is going to be the same. Like how we are going to handle CI/CD, how we are going to deploy it, where we are going to deploy it, whether we are going to deploy it under a load balancer or it is going to be a distributed architecture, how it is going to handle real time. All these are actually the on what is the system we are building and how much scale we are building in. The same thing applies for AI engineering as well. I think building the AI modules are very easy, like how we are building a REST API. It is very easy to build, but scaling those to the exact need and tracing, observability, reliability, those are all the software engineering principle which will get difficult for AI engineering, which will be little bit different from a normal backend because normal backend where when you are providing an input, you know what to expect as an output. But when it comes to AI, the deterministic output might not be expected each time. So even though you are hitting like an API to your LLM, the LLM won't respond the same thing again and again. It will be probabilistic. So you need to handle error handling. So what if, for example, you ask for JSON output from LLM? 9 out of 10 times, most of the LLM today can able to respond with a clear JSON structure, but the last 10th time it might miss some values, or it might broke that JSON structure. Now your system need to handle how you are going to handle it and how you are going to recover it. That is what makes your system production ready. So those are all the things which will be little bit different from a traditional backend engineering. But overall, as I said, 90 to 95% of the concept is going to be same, regardless of whether it is normal HTTP API or a
Yes. So you've made a very valid point, and I'm going to try to recap some of the points that you've made, which actually makes a lot of sense because if you look at AI engineering, I think 90% of the time it's still more about engineering, right? And then the 10% that remains is now about modeling, right? So the core concept of software engineering still applies even in this world of AI engineering. Things like reliability, things like looking at cost and performance, and then looking at architecture and system design, and even observabilities and monitoring. So these are the core of a production ready software, that is built by a backend engineer. So these things are still also applicable even when you're building AI agents and AI systems. So I don't
definitely.
think we have more ideas to throw in that regard.
Definitely, definitely. You made a very good point. Especially for example, cost and reliability is definitely something which will be very challenging with those systems. But we have built those systems before. If you take out AI, we have built optimized systems, and we have built reliable systems even before all these AI over the so the same principle apply over here as well. Only thing is certain caution need to be there. For example, before when we are deploying a backend where some operation is very long running process or very resource hungry, then it will deploy our resources, but it won't create a huge cost to it. That is the only difference between backend and AI engineering. Where in AI engineering, for example, if your AI agent is running in a loop and you are not tracing it, or you are not observing it, or you didn't put a budget constraint for your resources, then it will call your LLM and you are consuming tokens, more and more tokens, and you will end up consuming quite a bit of it. So you are basically paying for it. So those are all the small differences, but other than that, I think it is still resources. Whether it is token or whether it is your CPU or memory, it is going to be resources. It is the same like serverless architecture as well. In serverless architecture, if you are not stopping a function which is going in a loop, it will quickly call multiple function calls, then you will be paying a premium for it, because for each call you will be paying for it. Lambda functions or Firebase related functions, you need to be very very careful that you are handling those errors and having those guardrails in place. The same approach will apply for production ready systems. You need to plan for failures. So what are all the failures that can happen if you are building an AI agent, whether it is going to be autonomous agent, whether it is going to be a human human input based agent, then you need to plan what are all the failure scenario and how to make sure we are not depleting our resources, and how to make sure what is the hard stop for those, then we will be able to make it reliable.
Yes.
Cursor or Cloud Code, those are very good examples of it. For example, sometimes they say, okay, I'm not able to read, error reading your files, and they will be able to hot stop and ask, can I proceed? Otherwise, if they delete your system files or something, that is a non-recoverable action. So those kind of things is what we need to design when we
Of
are
course.
designing the agent.
Of course. So, from the points that you've raised, I think it all boils down to the fact that for you to be able to build a production ready AI systems, you definitely need to know how to build production ready, softwares and applications generally. And then you now infuse the knowledge that you have, building AI system into what you already have. And then that makes you to become a production ready AI engineer. All right. So that is a very valid point, and I also encourage backend engineers that, in as much as we have AI now, they shouldn't leave the fundamentals that they already have. they should even go more deeper into it, because all the concepts and tips and clean code tricks and all of that, AI is now able to help them do that. But one thing that still remains important is the fundamentals that they actually know, and how they can plan out problems and solve problems as engineers, which is very, very important. Now, let's move on to the next question. In as much as we have all this knowledge, there are still some mistakes that we see people make. I mean, backend engineers, we see them make in this area of AI engineering. So some of them might say, okay, since this is a new field, let me completely leave what I already know and then move towards this field. All right. Now, not knowing that where they are going to still needs the knowledge that they learned from becoming backend engineers. So I want you to help us. What are like the common mistakes that backend engineers make, and what are like the solutions that you can help to treat these mistakes?
I think once again, I think you answered in the previous phase where you mentioned the foundation. The foundation is what the mistake most of them make. For example, when they see a shiny example or tool, because now with AI in a booming market, every day you see new things coming up, new frameworks coming up, and new demos coming up. So automatically they will jump into one after another without knowing the depth of the problem. So it is similar to changing from, okay, I know Node.js, now I hit a roadblock, then I will go to Python, then I hit a roadblock, I will go to Rust. That it doesn't work. Software engineering is always about like how you incrementally build on top of things. So you don't need to chase each and every framework, but you need to know the fundamental of why that framework has been created and what problem it solves, whether that is the problem we wanted to solve, what is the short term, what is the long term approach for our problem. So that is what we need to think about, especially um, a, a simple example is like customer support board. A customer support board in an e-commerce setup is very different from a customer support board in a flight booking website, because for an e-commerce you already have a list of products. Okay, these are the list of products, and this is the API where you can query what are all the stocks which is available, and you will be able to handle that. But for a flight booking, it has its own complication, because booking alone, they might have single PNR, they might have multiple PNR. So there are a lot of complexities which will be involved, and they might have a flight booking along with hotel booking along with certain other details as well. So now, like static data, dynamic data, even though both boards are customer support board, where e-commerce data is going to be very very static most of the time, only certain information is dynamic, order specific information is dynamic. But for flight booking, everything is dynamic. So in order to get the information, you need to directly query from database and things like that. So that is where the domain actually dictates what kind of problem we are solving, rather than just cloning whatever is available then redoing it again and again. That won't scale. But you need to learn what is the problem, understand what is the fundamental concept which will apply for those problem, and then apply those which is needed. So that is where even in terms of reliability, observability, cost optimization, premature optimization is also not good. For a simple e-commerce board, or for a simple static website board you are creating, you don't need to create a very scalable system or anything. You can build a very simple RAG solution. But for a very complex call center kind of application where multiple queries comes in, where scalability matters, then you need to build a system which handles that load and things like that. So I think that is where many are making mistake, because the hype is real. There are a lot of things which is going on in this field, so automatically they jump from one hype to another hype. So they are not able to build actual system, but they are able to create like mm, yeah, like a notebook version of prototypes. But beyond that prototype, you still need that uh, fundamentals what you mentioned. I think understanding that fundamentals is what takes you from point one to point two, and after that, then you will figure out how to iterate from point two to three, four, five, and whether you want to improve on accuracy, then what you need to chase. Whether you want to improve on your data itself, then what you need to chase. So then you will learn from it, and you can incrementally build on top of it. Then you can able to architect. So I think
Awesome.
that is what I would say are common mistakes.
All right. So you made good points, especially the part where you mentioned that things in AI are dynamic, rather than sending the same input and always getting the same output. So it doesn't work like that in the AI engineering world. Things are dynamic, things changes. Even if you send the same input, your LLM most likely will return something different each time. So that is one mistake. I mean, that one thing that backend engineers comes with when they are trying to transition into AI engineering. They treat AI like a REST API, right? And they think that when they send in this input, that is what they are going to produce. They're going to produce always the same output, but that is not the case in AI engineering. So you need to use evaluation frameworks to actually measure what pass rate is rather than the exact string. So you don't check for the exact string, but you check if the response is actually what you wanted or if it passes a criteria that you actually set. All right. So another thing is shipping without monitoring. I understand that as a backend engineer, monitoring is important, but some persons think that it is not in the AI world, but it is a mistake, right? So you need to always make sure that you include all forms of observabilities, monitoring, and all of this. Check all the metrics that are
Right,
relevant to your
right,
production, all right? And move on like that. Then another thing is overusing agents. So we understand that once you are able to build agents, they become very cool to build and just continue building because most of the things that you would do manually, you would want an AI agent to help you automate it. But at that moment, you are overusing these agents. So you can just
yeah,
simply use an agent, build an agent that solves your specific task, and then you can manually do the rest, so that you have a system that you can still control. And then I think the next one is like ignoring cost until it's too late. So people just use these agents, use LLM anyhow, and not looking at the cost of tokens and all of that, which which can basically just hurt your finances if you are building for a company, right? So you need to take time and really dig deep into selecting models and making sure that you budget everything professionally so that you don't fall into large cost. And another thing is people tend to be building demos instead of systems. So if you're going to become an AI engineer, you need to focus on building production ready systems instead of building demos like you mentioned using Python notebooks to build all
yeah,
those demos and then
right,
calling
right,
yourself AI engineer. So I think you need to calm down, bring in the fundamentals that you've learned, and then use that knowledge to build systems that actually work in production, and then while saving cost, right? And then you now know, okay, that you really built systems. All
right.
right, so that makes a lot of sense. Thank you very much for sharing these tips. And I also have a lot other questions to ask, and we are going to proceed to some of them. But if you have anything to add based on what I've said so far, you can just let us know.
I think you summarized it very well. One additional point I would add is security as well, because in normal systems, security is also thought in a very different eyes. We monitor the input, we monitor the output, because since we know what is the output which is going to be there, then we will be able to secure it very well. But in AI, that is one thing which is ever evolving. For example, if you are building a kids related app which involves LLM, then you need to make sure the language which is used is kids friendly, and it is compliant with COPA, HIPAA compliant, and the same with when you are actually sharing some personally identifiable information to LLM, then you need to make sure to redact those information and get back. So those kind of secureness thought process is also something which need to be, because in a prototype stage these are all the things which we don't worry too much on, because it's working on your local machine, and you will go ahead and try it out with couple of test use cases, and you will go with that. But that is where on the production system that will also come into picture, because once the damage is done, it is very hard to recover back. So that is where I think when you are designing your production system, you need to take care of all these pieces and handle it accordingly. But other than that, I think you summarize the points very, very well with depth, especially around the cost and the reliability around the AI agent. So sometimes complexity adds, how to say that, it will blind your eyes. When you add very complex AI agent, you might think, okay, we have engineered something which is complex, and you might be proud of it. But what it will cause is, like, you don't know what is the exact output of it. You might miss a lot of use cases. So it's always good to go from one step at a time. Even if you are starting with a very simple agent, and you are able to handle, like, you are able to evaluate what is the input, what is the output, and okay, if I provide different set of input, what will be the output, and how to handle it, and go from there. All at one go will always be harder. Again, I will relate very similar to backend engineering. When you are designing database schema, you always design with one step at a time, then the system won't be very complex. But when you are designing with all the schema at one place, then it will become very rigid, and you might not able to change it back later on. So the same principle applies in AI engineering as well. If you design very complex system early on, even without knowing how it is going to be, then changing those once again for your need will become more rigid. So always go one step at a time and proceed.
All right. Thank you very much for that. We are going to proceed to like the next question. It's more like this is 2026. In fact, this is January, and a lot of persons would definitely want to switch careers to AI engineering. People that are backend engineers, this is one little step forward into the AI world. So I want to know from your experience, building different AI systems, what is like the roadmap that someone can start? Where should they start from in order for them to be able to start building production ready AI systems? What are the roadmaps that they need to follow? What should they learn? And yeah, so can you help me break that down?
Sure. I think roadmap, in the sense, mostly my preference is always practical, project driven. So in this case, start with very simple, like a simple chatbot, that is like RAG systems, where you will be able to process some user query and able to output what is needed, either with the LLM's knowledge or with your static knowledge. And then slowly go into agentic RAG, where you can call functions. If the user is asking, hey, what is the status of my flight booking, is there any delay for my flight, then you can get that information from live database or live information and provide that information. Those kind of system, those are the initial starting point. And after that, after the rack system, you can go one step ahead, like agentic systems. So agentic systems have multiple branches, like workflows. For example, workflows are something which you guys are already building many of the time. So for example, for a backend engineer, you might have already built many workflows, like, hey, if a user follows another user, then send an email notification or send a Slack notification, or when someone pays in Stripe, then call this webhook, and that webhook will store that Stripe information, store that payment status, like, okay, this person has paid for this, and they will be enabled whatever subscription that need to be enabled. So it's a workflow. When a person pays, Stripe will be called. On Stripe will verify, and after that it will come into the webhook, and webhook will store that information to database, and database information will be shown in the UI. So the similar workflow can be used in AI systems as well. For example, AI workflows where there are a lot of products like video generation products you might have seen, where the script will be created using LLM, and for that script images will be created, and for those images, along with that, small video clippings using VO3 or video LLMs, where it will provide output with video, images, and text, and then combining all those and create a clip like a YouTube Shorts video or something like that. So it's a workflow. These workflows are the next step after RAG systems, and then AI agentic tools, in the sense it can either be autonomous or human input based tools. A good example is what especially for backend programmers, you might have already used GitHub Copilot, Cursor, or Claude Code, or any tools related to that for your coding and pair programming together with AI. So those tools are actually advanced agentic tools. What they are actually doing, like when you are actually prompting, hey, build this or debug this in my code base, then it will index your code base, and it will fetch where that information is, and based on that it will suggest, okay, these are the steps or these are the tasks we can do, can I proceed? Then you will say, no, don't proceed, but this is where I suspect, or this is what I wanted to build, this is not how I wanted to build. Then you will provide your input. Then once you are very satisfied, then you will say, like, build it. Then it will start to build. So these kind of systems which thinks on its own, which reasons on its own, based on your input it will reason, and it will provide different path. So you need to build that system. So those architectures are much more complex than just one-to-one communication to LLM APIs. Like, okay, this is my query and I am communicating. Rather, these systems will follow multiple paths. When you are asking, hey, write a document, then it will follow a different path. When you are asking, hey, can you do a code review for this file, then it follows a different path. When you are asking, can you build this front end for me, then it will follow a different path. So that is where the AI agent will reason your query, and then decide which path to take and which module to call, and so on. So the complexity will go more depth, and these kind of systems are actually used in many large businesses nowadays. Even banks, for example, in bank, when you are actually asking for loan application, now loan applications are semi automated with AI driven systems. Like AI will already score, okay, for this person is asking for this home loan, and this is the home, and this is the detail of that home, and this is the person's detail, and this is the person's credit score. And based on this information, whether to provide this loan or what are all the risk, and it will do all the analysis, and it will provide detail of, okay, these are the risks. Another example is legal. This is one of the very booming industry, I would say. Legal is one another place where automation is happening. For example, before, even for a simple lawyer, case intake takes a lot of time, because you need to have one-on-one, and you need to provide document, and you need to record yourself and provide information like what has happened, what is the sequence of event, and all those things. Now with the AI, you just record it and you provide it, like how Google Meet or Zoom transcribe your data. Automatically the AI system transcribe all this information as well as the document you provided, and it will create a summary for the lawyer, like these are the sequence of event that happened, and this is the details. Is there any missing details which need to be asked? Then automatically AI agent will ask for those detail. Okay, you have provided this detail, these are the missing information, can you provide this missing information? So now the lawyer's role will just be thinking about their lawyer duty rather than thinking about data collection. So those kind of things is what advanced AI agents are currently being deployed in actual production systems. Beyond textual and these input, there are other niche based applications that has been built as well. So those are like voice based application. I think those are also quite popular. I would say many industries are already automating some of the booking system, because live voice related AI are getting more popular now. For example, receptionist, instead of deploying a human receptionist, nowadays there are dental clinics and things. When you call a receptionist phone number, they respond with the AI. So those kind of systems are getting deployed. It is in early stage, I would say, compared to textual output. I think voice is in early stage, but I believe in couple of years time, maybe this year and next year time, there will be a lot of actual production deployment which happens in voice related output as well. So beyond text, I think it will move further. But in terms of roadmap, I think that is the key, like simple rack system, and then go into AI workflows, and then go into AI agents, and then simple AI agents, and then complex AI agent, where the complex AI agent is not exactly the agent itself, but the actual whatever we have discussed, the fundamentals of backend, like your monitoring system, how you are going to test it, how you are going to evaluate it, how you are going to secure it, how you are going to do the cost optimization, what are all the guardrails you need to keep. Like if some AA agent is going rogue, then how do you make sure to circuit break it? So those are all the things that makes a complex agentic system. So I think that is the flow to go with.
All
Go
right.
from very simple to more complex.
Yes, yes, of course. That's like the best approach to learn anything, starting from the known to the unknown. Yeah. So I think I have a pattern that I carve for myself that I used to learn something new. So when I also started learning, AI engineering and all of that, I actually use this pattern. So first of all, my goal is to learn whatever I'm learning practically. So when I started learning backend engineering, my goal was learn backend engineering practically and all of that. So what I did was to break this goal down into three paths. So the first one is learn, the second one is build, and then the third one is grow. So under the learn, I look at where I am, what knowledge do I have, and then I start from what knowledge I have. I look at courses, textbooks, whatever thing that I could get to learn, practically using these courses and this content, right? And then after I'm done learning practically, I move to the build part. So in this section, I started looking at courses that involve me, actively building stuff. Like I could take a course like Build 14 or Build 5 AI agents, Build 20 AI agents, all these kind of courses. So I take these kind of courses to encourage me to build stuff. And then once I was able to, build agents for myself, and then move into the growth part where I start looking at, going deeper into agents and going deeper into AI workflows and multi-agent and all of this. But because I already have knowledge of theories and also I've built some agent, it's now become very easy for me to now go deeper into this. All right. So there is generally roadmaps.sh basically has a detailed roadmap that covers everything that you need to learn first if you're starting out as an AI engineer, right, there is something that, some of the theories that you need to learn, the beginning stage, and then you move down to like the more advanced stage. So I would encourage everybody to just check it out right there. All right. So I'm actually learning a lot from the podcast. We are going to move real quick and forward. So let's talk about like career shift. As a backend engineer, I have now decided that I want to learn AI engineering. Now I have these roadmaps to follow. What would be like some of the things that I would bring into AI engineering? So, for example, we can see that as a backend engineer, I know what states mean, I know what databases are, I know what caching, queues, all this stuff. I know what they mean. Now, are these things going to be in AI engineering? Should I expect them, or I should, just leave all this knowledge that I already have, and then focus on the new knowledge that I want to pick? Is that how AI engineering is, or there is a place where they meet, and I can bring my knowledge from backend engineering to AI engineering, or vice versa? Just tell us how it looks like.
Got it, got it. Very, very good question, Solomon. I think no, you don't need to throw any of the knowledge. In that sense, for example, maybe I will go with the example here. In a normal backend system, when you are building a search engine, for like not search engine, but on a website, you are building a search where you search on certain terms and you directly search in your, if it is a very simple system, then you will search it in your database directly like Postgres or MongoDB, and you either use regex based or you will use some fuzzy logic
Mhm.
to search there and get that information, and you will be fine, and you will be able to display the result for that search in an e-commerce or things. In an AI, the same approach will work as well. In AI as well, you are doing the same search. So when I am asking what is the cost of this product, then you are not directly searching your keyword based search, but you are searching semantic based search. Like you already have a data, like these are the products I am selling, and when user is asking what is the cost of this product, then you are semantically searching instead of keywords, because this is English text. So you are searching semantically in a database. So that database is called vector database. So whatever learning you have done, the same learning will approach over here. Either you use vector database or graph database, still it is going to be some sort of the same, the principle. The search differs because you are searching semantically, like okay, cost and this product, and it will fetch, okay, this is the product and this is the cost, and based on that it will find information. So when vector database will be very useful for smaller RAG application, but when it becomes more complex, when you have more relationships between your items, then you will go for more complex databases like graph databases. So at the end of the day, the concept of database and searching and all those things are going to be like the same. You are going to retrieve data, whether it is a traditional database like SQL database, or whether it is a vector database, whether it is a graph database. You are going to apply the same principle and same mindset what you have built. But yeah, the tools and frameworks of calling those might differ a little bit. Those are all the differences. The same applies for caching. For example, in a normal API we just employ Redis cache, but here these caches are more key based caches, like okay, I'm fetching this page content, or in Udemy, they list down hundreds of courses. So if they are hitting their database for each time to list down all those courses again and again and course information again and again, then for millions of users it will consume a lot of resources, and database will become a bottleneck for scaling. So what they will do is like they will deploy more in memory databases like Redis, where it will be like based on the key, and it will fetch, okay, this information hasn't changed for last 30 days, so you get those information from the cache. This is in a traditional backend sense. The same applies for LLM as well. LLM cache is very similar to that. Only difference is what you are basically going to cache. How the cache hit will happen will differ, because here very easy to predict. Okay, this is the data which has been asked, but here it is little bit difficult to predict what is the data which is asked. For example, I might be asking the question in this way: what is the cost of XYZ product? And some other user will be asking the same question in a very different way: hey, do you have this product? If you have this product, what is the cost of it? Now, even though the questions are same, I ask the same question, another person also asks the same question, but our language is different. Our details are different. So now the caching will also need to make sure to understand this and able to have a hit for that cache. So that is where the principle might little bit change, but at the end of the day, the foundation is going to be still it is a cache, and we are retrieving data from the cache. So I think all the basic principles what we have done, I think I can go further as well, like evaluation, testing, reliability, deployment. Everywhere it is going to be the same, but little bit different difference will be there. Maybe I will finish with one last example, like HTTP API, where you will have a hot timeout. Like, okay, if this API doesn't respond for 10 seconds, then throw an error. The timeout for this API will be 10 seconds. But for LLM API, we can't easily say, and route through HTTP API. For example, AI agent might take very long period to process the information, think through it, and create a plan for it and do that. So then you need to plan accordingly. HTTP API might not work, maybe WebSockets will work, or maybe server sent events will work, or probably we need to design in a way for a even more complex architecture, like PubSub need to be involved, where the event will be triggered, AI agent will work in an autonomous state, and it will just send the details, like, okay, it will stream, okay, this is the thinking process. So that is what we see in Cursor, or in Google Copilot, where you put an detail and it will start thinking, and it will show some debug information, like, okay, I'm thinking this way, I'm thinking that way, and then it will share what is the plan. So that those kind of API details will change, but the fundamentals is not going to change at all. So a backend engineer can easily become an AI engineer. You just need to understand the differences, and then, as you said, learn, build. That is the approach. Like, learn at this stage, you understand what you know, what you doesn't know, and then build. Try small examples. One example, second AI agent example, third AI agent example, fourth AI agent. Automatically, you will incrementally build yourself. So I think it's a consistency always matters when you are learning. So if you put a consistent effort, you will automatically learn.
All right. So that summarizes all of that. Thank you very much for sharing. And it's also nice because these little differences is, what you need to learn as a backend engineer to be able to surpass, the different other persons who haven't been able to learn these differences, right? So with this in mind, I get to understand that you are hosting a bootcamp, partnering with Mastering Backend to run a bootcamp, which is going to show backend engineers exactly how to learn these little differences, right? And then be
Yes.
able to build production ready AI systems. So do you mind talking about that and how it's going to change backend engineers and help them become production ready AI engineers rather?
Exactly. Thanks for sharing. First of all, yeah, I haven't talked about the boot camp much. So, in partnership with Mastering Backend, we are running a 6 week boot camp exclusively for backend engineers to, pick up the AA engineering skills through practical applications. Like, week on week, we focus on building different demos and different production ready systems, and architecting different production ready systems. So, slowly building from basic to more advanced AI agentic system. So that is the goal of that bootcamp. How it helps backend engineer is, reading through a tutorial or going over a YouTube video will get you somewhere in terms of a knowledge gap. You understood, okay, there are systems which is in place, but this will prepare you. The bootcamp will prepare you for actually implementing. So instead of knowing what is possible, you will be able to implement what is possible. So that is the focus for the boot camp. End of 6 week boot camp, you will be very confident that you can able to either integrate AI systems in your legacy system, or you can build a standalone AI systems in a scalable way, on production ready way. Instead of just demos, watching demos, you will be able to be ready for building those systems. So that is the core focus of those of the bootcamp basically.
All right. Yeah, so I believe I can share more information about the bootcamp. So one thing that I've realized, right, learning from YouTube and external resources and all of that is it falls under the three categories that I've mentioned before. So we have the learn, build, and grow. So when you learn from YouTube and all of this, you're acquiring, especially if you're just starting out learning a particular skill, you're acquiring this knowledge, the theoretical part, and sometimes, the practical part, following what the instructor is talking about. So you are still under the learn and the build part. But for you to actually move to the growth part, you need, somebody that has, built out these systems before, systems that are actually running, and then this person actually shows you exactly how it's done. So that is exactly what we are going to be doing in the boot camp, because there you're going to build out lots of production ready AI systems, and you're going to build alongside the instructor in this boot camp. So it's going to start this January, and we are going to share links and every information that you need for you to join, and we can't wait to see you there. So, but before we move on, I would still like to know from you, like the different, products or systems that we are going to be building. So you can just list them out and the approaches we are going to take to build out this system.
Okay. So in that sense, as I said, all weeks we are actually focusing on different layers. So in the first week, as I said, like we will be focusing on more simpler system like chatbots, where you can have one-on-one replies from LLM, and you can able to connect to simple tools like function calling, and able to build simple chatbots, production level chatbots. And in the next week, we will directly jump into simple AI agents and workflows, where you will be able to build a agent which will think, which will reason, and which will able to take path, whether to call a tool, whether to retrieve data from database, or whether to retrieve information from web. So it will choose, and it will be able to provide summary or details from there. So we can build a array of small projects as well, like one of the project I mentioned, like legal case intake flow. We will be building legal case intake flow for AI agent, how we can feed information, and how AI agent will act and ask questions that we will be doing. And in the third week, from third week itself, we will go more advanced, like how to make a prototype to production. So what are all the techniques we need to learn, like evaluation, security, and reliability, how we are going to deploy it to production, what are all the checklist you need to keep for deploying it to production, and how you will iterate further from initial beta version to actual version, how you are going to iterate it, and how you are going to identify and track any bug which is happening in production system, so even before user is notifying you. So those things we will be learning from third week onwards. And in the next weeks, we will go into system architecture itself. We will go through different use cases, from simple system to more complex systems, including not just text, but also other form of input as well, like voice input, text input. And then we will go use case by use cases, which is actually there in industry. For example, in Google Meet, you might have seen a transcriber which is transcribing and providing a summary of your transcribed information. What is the architecture which is powering it? We will learn that. And in Gmail, for example, when you are drafting an email, it will automatically suggest an autocomplete. How this system is built, how they know what need to be autocomplete for this email thread, how they are doing it, and what is the scalable way to do that. If they are providing multiple choices, how we can build that system. So this is small example, and then we will see the same way another systems which is actually in production. So we will see some of the case studies, you can say, while going through the software architecture, and understand if we are building that either as a business or as a product feature, then what is the system architecture we will build, that we will learn. So I think the first few weeks will be focusing on fundamentals and basics, and the next weeks will be focusing on production readiness. So that is how the bootcamp has been divided. You will be building 6 to 8 demos, including some of the demos which has been pre-built, that will also be shown. So that is what the bootcamp will be comprised of. Since it's a bootcamp, it is not a course. There will be expectation from your end as well in terms of time commitment. So you need to provide that time commitment to build and learn, so that it sticks with you. So by the end of the boot camp, you will, as Solomon mentioned, it is not like YouTube course, but it will stick with you to grow further. You won't feel like, I know this but I can't build this. No, in the boot camp, you know this, you will be able to build this. So that's the idea behind.
Nice. Thank you very much for sharing that. And I look forward to seeing everybody listening to us in the boot camp, because it's going to be very, very educative. And we are going to make sure that you are able to build out these, complex AI products once and for all. And definitely, I am going to make sure of that. So thank you very much for tuning in. And we say thank you very much and a happy new year.
Yeah. Thanks, Solomon. Thank
All
you,
right.
guys.
So before we close, some of the links for you to follow us on social media and also follow Param on his social media are going to be shared on the description of this video. So you can also check that and get access to these informations that we provide, including the roadmap from roadmap.sh that we are going to be sharing. All right. So thank you very much and see you next time.
Yeah. Thank you.